Gas dynamic flow field can be reversible adiabatic or it can be irreversible adiabatic case to case. Right now we are going to learn the gas dynamic principles under the considerations of the flow field is adiabatic and reversible. And subsequent chapters and the other portions, we will also take up. There are flow processes in the gas dynamic flow phenomenon where the flow field is also adiabatic but irreversible. Formulations are completely different. So the most familiar process is isentropic process. Isentropic process is also called as reversible, ideal process. It is an ideal process, reversible adiabatic process. Basic equations of compressible flows. So much we have done, we don't need to do so much. If you remember this formula, the problem can be solved in 1 minute. And everything is, that's what I'm going to do. We have done using the thermodynamic approach. We will do this problem using gas dynamic approach. For this, there are formulations required. Okay. Isentropic relation is as easily kept as P2 by P1 is equal to rho 2 by rho 1 power gamma is equal to T2 by T1 power gamma by gamma minus 1 will be seen differently in gas dynamics. What is that? We'll see. That's what I call under the heading called basic equations of compressible flows. That is, write down the isentropic relations again between two stations. P2 by P1 is equal to rho 2 by rho 1 power gamma is equal to T2 by T1 gamma. One caution I give you, you can use these formulations to connect temperature, density and pressure between two stations only when the process is announced as isentropic, not anything else. Don't look at the complete formulation. Energy equation H1 plus V1 square by 2 is equal to H2 plus V2 square by 2. In the flow, this is also approved, and this equation is applicable for both, valid for both reversible adiabatic and irreversible. Please remember this, I keep telling you number of times. These are all isentropic flow equations. This is also applicable for irreversible adiabatic also. Valid for both reversible and irreversible adiabatic flow process. These formulations are valid only for reversible adiabatic. I want to combine these two and say they are the basic compressible flow equations. Nothing more. Combine these two systematically, replacing velocity into Mach number, and you don't see them differently, and there are popular equations which are 3 in number. Okay, so let us try to take up this and process first of all. Take up this CPT1 plus velocity, I want to see it as Mach number. Every formulation in gas dynamics, we want to see them in terms of Mach number only, not in terms of velocity. That is the changeover we are trying to bring in. How do you write V1 square? M1 is equal to V1 by A1. V1 is M1 square. It is A1 square by 2 is equal to CPT2 plus M2 square A2 square by 2. This is one step. CP we will write as what? Gamma. What is CP? Gamma R by gamma minus 1, right? Look at previous. What is CP? You should remember gamma R by gamma minus 1. T1 plus M1 square by 2. What is A1 square? See, energy equation I am converting into a different formulation in terms of Mach number. I am processing only energy equation. I am not connecting this one to this right now. Please have clarity. I'm just making some changes in energy equation format. Changeover of that format has led to Bernoulli equation, compressible Bernoulli. Now this is going to give us a different format. Everything origin is energy equation only. We are not. You can solve the entire problem using this too, but it becomes laborious when you don't formulate. Okay, now, so is it not energy equation now? Still energy equation. This is still energy equation. We are not doing anything. We are just substituting the parameters and replacing them, trying to convert in terms of Mach numbers. What is A1 square? A1 equal to square root gamma r T1. This becomes A1 A gamma r T1 is equal to gamma r by gamma minus 1 T2 plus M2 square by 2 gamma r T2. Fine. I just want you to do this. T2 by T1 is equal to, try all of you. I want a final expression of T2 by T1 is equal to. Do whatever you want to do. Take T1 common. Gamma R can go away, gamma R. So what is the simplest possible way of doing this? This I can write it to be T1 by gamma minus 1 plus M1 square by 2. Gamma R is getting cancelled. T2 by plus M2 square by 2 into T2. Take T1 common. Take T2 common. That's all. What is T2 by T1? T2 by T1 is equal to 1 plus gamma minus 1 by 2 M1 square by 1 plus. What is this equation? Is it an isentropic? It is an energy equation written in a different format. It is still an energy equation in terms of temperature and Mach number. Original energy equation is this. We just made some substitutions and arrangements, and I am showing you this in this format. What is still it is? Still it is energy equation only in terms of this format. Don't lose the track. Okay. Now I apply, so this equation is valid for both what? Write down, valid for both reversible and irreversible adiabatic flow process. That equation only. So that can be an isentropic relation, that can be irreversible adiabatic flow equation also. We can use that because that is just finally tell me what is this equation. This equation is nothing but this. No more changes. Only we have made substitutions of velocity in terms of Mach number and enthalpy in terms of temperature and made some substitutions. Now, recall isentropic relations. Isentropic relations. Take up this and this. P2 by P1 can be written as what? P2 by P1 is equal to T2 by T1 power gamma by gamma. So T2 by T1 I am writing this. So P2 by P1 can be written as 1 plus gamma minus 1 by 2 M1 square by 1 plus gamma minus 1 by 2 M2 square power gamma by gamma minus 1. What is rho 2 by rho 1? These two. 1 by gamma minus 1. T2 by T1 is equal to, rho 2 by rho 1 is equal to 1 plus gamma minus 1 by 2 M1 square by 1 plus gamma minus 1 by 2 M2 square power 1 by, these are called basic compressible flow equations. These three. These two are specially isentropic flow relations. This is applicable for both isentropic and irreversible adiabatic. Understand? Isentropic flow process. Now take up that problem and solve in a simplest possible way. Compressible flow approach. We have this. We can use directly this. P naught by P infinity is equal to 1 plus gamma minus 1 by 2 M infinity square. This becomes 0. P naught by P, there is a formula. P naught and P is known, M1 is known. M infinity. M infinity is what? Use this formula for the same problem. Same Pitot Pro problem for compressible flow approach. Take up this formula. What is P2 here? P2 is P naught. P1 is P infinity is equal to 1 plus M1 is M infinity by 1 plus M2. What is M2 at the Pitot? 1 plus 0. So nothing is there. Power. Find out M infinity directly. Now we understand compressible or incompressible, the problem. The problem given is what? This particular problem is connected to what zone? Compressible. This is a way to identify whether the connected to incompressible or compressible. Now we cannot use definitely incompressible Bernoulli equation to solve this. That is the conclusion. Isn't it? Did you understand the entire grasp of the problem? Now, what is Mach number? V infinity by square root of gamma r T infinity. You have T infinity. Find out V infinity. How? Same thing. 157. Point. Practice this problem. Which method you take up, that's your choice. I go by this. Simple or not? Very simple. Now we have a new point to know whether the problem given in the problem statement is related to incompressible medium or compressible approach. Mach number is 0.5. It is more than 0.3. It is compressible. So we cannot use incompressible Bernoulli approach, incompressible approach.